Let us start with preparation of carboxylic acids from nitriles and amides. Right now, first of all, the method used is like hydrolysis. So, nitriles or amides, they have to be hydrolyzed, and hydrolysis is done in presence of catalytic quantity of H plus or OH minus. So this is basically the condition, right, for hydrolysis, either in presence of H plus or OH minus. Now, you must know that when you start with nitriles first of all get hydrolyzed to amides, and amides get further hydrolyzed to carboxylic acids. And I would give you a simple, equation that you can start with RC triple bond N. Now you can perform your hydrolysis in presence of acid or base. Suppose you start with H2O in presence of H plus, let's say, and heat. The first primary product that you get is RCO NH2. This is, a nitrile forming an amide. And this amide would further get hydrolyzed. Now here once again, you already have, situation in which you've used acid as a catalyst. So the same medium continues, and eventually you end up in getting C double bond O and OH, and along with that NH4 plus ions separated. The same reaction if done in basic medium. If you perform the same reaction in basic medium, you have H2O and OH minus, you heat. The first thing that you get is RCO NH2, an amide, which eventually in the same medium would form RCOO minus plus NH3. The salt which is formed, the carboxylate salt which is formed here, can be acidified to get RCOOH. So basically, medium can be acidic or basic. So if you're taking acidic medium, you end up in getting a carboxylic acid with NH4 or ammonium salt, as you can see here. Whereas if you take an alkaline medium, then you get an amide which further gets converted into a salt of carboxylic acid and ammonia. The salt is further converted into corresponding acid by protonation. So these are, this is a simple way of doing it. I can even give you one or two more example. One of the other examples we can try up would be like, take an aromatic nitrile. This is like, you can call it as benzonitrile, right? Or benzene carbonitrile. Now, more IUPAC name would be benzene carbonitrile. You can use water, and you can use acidic conditions and heat. You end up in getting CONH2. This is like benzamide And this benzamide would further, under same conditions, right? Because you cannot change the medium now. So under same conditions, you continue heating, you finally get this is benzoic acid. So very simple thing. I can normally you have to know the mechanism also, right? But this I would be doing in the regular class where I would be showing you how this goes, right? But here you can just get the products, and you know how to get the products. That's more important, right? Okay, let us start with the next method, which is the Untitled method. Now, first of all, let us understand what this method is all about. This method is used to convert one carboxylic acid into next higher homologue. So this is used for conversion of one carboxylic acid into next higher homologue. So basically it increases the carbon skeleton. Now how does this happen? So let us start with any one carboxylic acid. We would take a general form R, C, double bond O and OH. First of all, we convert this into a corresponding acid chloride by taking thionyl chloride. We can get this RCO Cl plus SO2 plus HCl. Now this RCO Cl is made to react with CH2N2. This CH2N2 is called a diazomethane. Now this diazomethane has this, let us look at the Lewis structure to know what exactly happens here. First of all, I'll give you the product, what goes here. This would convert itself into RCO, CH, and then N2. Now, upon heating this is basically a diazo ketone, as they call it. So if you want to write the name, it is diazo ketone. And this diazo ketone, upon heating, it has a good leaving group. It undergoes a rearrangement which is referred to as Wolff rearrangement. I would show you how this happens, but this would, form R, or let us say it gives you RCH double bond C double bond O plus N2. Right? This is basically a ketene. Ketene because here you have a ketonic group and you have a double bond, so this is called a ketene, and this ketene finally would undergo hydrolysis, and hydrolysis is done with water. Yeah, you can, it is fine if you use directly water because this is quite reactive, and it would give you R, single bond CH, double bond C, and then you have OH and OH, which would eventually give you the tautomerization would give you RCH2 C double bond O and OH. Here we just write tautomerization. All right. So this is the method, and if you closely observe, you started with RCOOH, and now you have carboxylic acid with 1 CH2 more. So carboxylic acid gets converted into the higher homologue. Now I would also show you how what mechanism this follows. So let me show you how this goes. See, your diazomethane has this unique structure, right? CH2 and this has a negative charge and this is a positive charge. This is diazomethane. And this diazomethane undergoes, resonance to generate a carbanion. So we have something like this. Right? This is one of the resonating forms. Now, when you allow this to react with an acid chloride, which you have already got. So when this is made to react with an acid chloride, your acid chloride has R, C double bond O and Cl, which has a good leaving group, which is chlorine here. The moment attack happens from carbon, pi bond collapses onto oxygen. As it collapses onto oxygen, what you get is R, C, O minus, the leaving group, and here you have CH2N2, right? Now this moves here and the leaving group leaves. Oh, I can put the correct color of arrows, so just wait. You can have this comes here and this goes out, and what we get here is minus Cl, and you have R, C double bond O, CH, N triple bond N. This is how things work out, and I think CH2, and yeah, this is how it goes, right? Now you know that chlorine which is separated, right, it can generally it would create a kind of you can have see this carbon moves in, and this is what we have. But now the chlorine which is separated would act as a base and would pull H out, because CH is surrounded by two strong withdrawing groups, so hydrogens become acidic, right? And you have this happening, right? So let us get this carbanion once again. R, C double bond O, and then we have CH here, and then we have this N triple bond N. And remember, N triple bond N is a very good leaving group, and now when you heat, there is this rearrangement which is going to happen. So just look at the rearrangement now. This moves here, right? This goes here and this goes here. Leaving group has to leave, so now you have R, CH double bond C double bond O, your ketene. and you have nitrogen separated. This is what we call as Wolff's rearrangement. And once you've got your ketene, I think you don't have to worry. You got your ketene now, so that ketene would undergo hydrolysis to form product. So after that, things are simple, right? So I have given you the full, definition of how it goes, right? So let us, group this up and let us put it all together. This is the basic mechanism of how, the reaction happens. So this was the fourth method. Let us move on to the remaining methods for making carboxylic acids.